I'm sorry, I've been interrupted by, or my internet has been interrupted. So I was just saying that we dip the blotting paper in a chlorophyll solution, and as the chlorophyll solution diffuses along the cellulose blotting paper, the intermolecular spaces will separate the pigment, and the pigments will diffuse in different speeds according to the size and molecular weight of the pigments, and therefore you will have separation of the pigments into different colors. This is an interesting experiment that we call paper chromatography. Paper because we use blotting paper and it is used to separate different molecules. Of course, the molecules that are smaller in size will diffuse faster and will be at the beginning, at the top in advance, and the heaviest molecules will be at the back. So this is very important to separate, for example, the pigments that are present in spinach leaves. Here on this diagram that I was using to explain the experiment of the blotting paper, we have on the x-axis the wavelength, and on the y-axis we have the absorbance. And of course, you can see again that chlorophyll A has two peaks of absorption of light, and chlorophyll B has two different peaks of absorption, but that are very close to the absorption of, or the absorption range of chlorophyll A. The photosynthetic pigments can be divided. This is an interesting diagram. They can be divided into principal pigments and accessory pigments. The principal pigments include chlorophyll A in green plants and in bacteria. Bacteriochlorophyll is a principal pigment, but in bacteria. The accessory pigments include chlorophylls B, C, D that are also green, carotenoids that are yellow, phycobilins that are blue. Carotenoids include carotene and xanthophyll, which is yellow. Phycobilins include phycoerythrin, that is red, and phycocyanin, that is blue. So we have two major groups of photosynthetic pigments, the chlorophylls, including chlorophyll A and chlorophyll B, and the carotenoids. These are the major ones. So among all the pigments that we have mentioned in the previous diagram, the chlorophylls in general, chlorophyll A and chlorophyll B, C, and D, and the carotenoids are the major groups of photosynthetic pigments. Some of them are principal, as you can see, chlorophyll A, and others are accessory, and will be very soon knowing the difference between the main pigment and the accessory pigment. However, whether we are belonging to the main pigment group or to the accessory pigment group, they are able of absorbing light energy, and therefore they get energized, they become activated, they become excited. All these are synonymous groups or synonymous terms. So what do we mean by being excited? We mean that there will be charge separation, and the charge that will be separated from the molecule of chlorophyll will be an electron. And when the electron leaves the molecule that has been excited, there will be like an empty space where there is no electron. By electron holes, we don't mean a physical hole or a physical empty space, but we mean the absence of an electron. So these pigments are capable of being excited after having absorbed light energy, and this excitation in the form of a released electron, of course, that electron will have a very high energy, and this will initiate the process of photosynthesis. Again, we say that chlorophyll A will absorb best in the blue range, in the red range, which are optimal for photosynthesis and will reflect green light. So if the blue range and the red range are the optimal ranges for photosynthesis. And if chlorophyll A is the one that absorbs the best in the blue range and in the red range, then definitely chlorophyll A will be the most efficient and important pigment for photosynthesis. On the other hand, the accessory pigments will be used to absorb energy in a wider range because, of course, they have different ranges that differs from that of chlorophyll A. So they are accessory or they are assistants to chlorophyll. They help chlorophyll in two ways. The first way is that they have a slightly different molecular structure than chlorophyll A, and therefore they will absorb a different range of wavelength, and therefore they are broadening or enlarging the wavelength range of chlorophyll A. But the second important function that they will funnel this energy onto chlorophyll A, meaning that first of all, they are different in molecular. I think that I would rather put this number